Hello everybody, I'm the pre-Dr. Bennett, and today I'm going to be doing Khan Academy's MCAT Biomolecules Prep Enzyme Structure and Function questions. There's 10 questions in this problem set, and I'm a little bit sick today, but we're going to make it through it together. All right, enzymes catalyze biochemical reactions by altering which of the following quantities associated with the reaction? Okay, so enzymes, catalysts. So we're talking about change in activation energy. So the possible answers are the change in Gibbs free energy. Absolutely no. They teach you that like day one in biochem. The activation energy. Okay, I think that one's it. The enthalpy of formation, the equilibrium constant. Yes, and it was the activation energy. Enzymes just allow for act as a catalyst to allow for the reaction to happen easier by requiring less energy for the activation. As that word kind of describes it. Okay, so phosphoglucomutase, which catalyzes the formation of glucose 6-phosphate from glucose 1-phosphate. This is a glycolysis question. Well, maybe not glycolysis question, but has to do with glycolysis. Is best classified as which of the following enzyme types? So a phosphoglucomutase is best classified as which of the following enzyme types? And I just wanted to tell the whole world that I was adding in the S there. I'm not sure if Sal meant for there to not be an S at the end of type, but which of the following enzyme type? I guess that makes sense. I don't know. I like having an S at the end of it. Okay, choose one answer. Kinase, oxidoreductase, isomerase, lyase. Well, even if we didn't know glycolysis, we could look at the formation of glucose 6-phosphate. So on a glucose, you're going to the 6 carbon to put the phosphate on from glucose 1-phosphate. Okay, so we had glucose 1-phosphate. The phosphate was on the 1 carbon. Then this enzyme happened, and now the phosphate is on the 6 carbon. What that means is that you have the same structure, same formula, different structure. That is an isomerase. Okie dokie. So, question 2, which of the following molecules cannot be classified as an enzymatic cofactor? Okay, enzymatic cofactor. Cofactors help reactions happen. I'm trying to just think of anything I know. That's just the first thing that pops into my head. Okay, so heme. I don't know. Valine. I doubt it. Magnesium. Possibly. Maybe I forgot what a cofactor was. And then FAD. I don't think FAD, and I don't think valine. Because of those, I don't think heme as well. I'm going to go with magnesium. Oh, no, it was wrong. Oh, I feel stupid. It's the first one I've gotten wrong on here. All right, what's the correct answer? It's valine. I'm not going to lie to you people. I just clicked through all the answers. Okay, let's find out why it was valine. A cofactor is a non-organic molecule whose presence is necessary for proper function of an enzyme. A non-organic molecule. Okay. Valine is an organic molecule. Cannot be classified. Oh, oh my God. When I was reading that first hint, I was thinking like, valine's an organic molecule. What you talking about, Sal? Oh my God, people, literally the cardinal sin of the MCAT is not answering a question. The second sin, you're gonna need one of the biggest indulgements that the Church of AMC has to offer to forgive you for this one. But to read a question and not see not. I did not see not. The answer was, which of the following molecules cannot be classified as an enzymatic cofactor? I read it as which of the following molecules can be classified as an enzymatic cofactor. Dang. I was on a search for enzymatic cofactors. I probably would have picked valine. All right. Well, you live and you learn. Okay, question number 4. In order to analyze the catalytic effect of 2 different enzymes on the same chemical reaction, it is best to compare which of the following quantities. Okay, we want to analyze catalytic effect, 2 different enzymes, same substrate. What is best to compare? Okay, the differences in enthalpy between the reactants and products, the differences in entropy between the reactants and products, the differences in free energy between the reactants and products, the difference between transition state energies. Okay, I assume that if we're talking about catalytic efficiency, then we don't necessarily care about the products, right? We care about the transition state energies, because that's like the definition of an enzyme, is how low can you get that transition state energy, right? Yes, and that was the correct answer. Okay, the active site of an enzyme E, which catalyzes a reaction X, is partially denatured. It's only slightly dead. Which of the following quantities associated with X is most likely to be affected by the partial denaturation of E compared to the native form of E? All right, so E catalyzes X. Which of the following quantities associated with X will be affected by this denaturation? Is it going to be the equilibrium constant? Is it going to be the Boltzmann constant? Boltzmann constant. The heat of reaction, or the rate constant? So if it's partially denatured, which of the following? The rate constant. Doesn't the rate constant, isn't that a factor of the enzyme? The heat of the reaction, I don't think so, because if you're talking about the individual reaction, it's going to be the same no matter what. It just might be slower, which made me think rate. But rate constant, I think, is a like a quality of the enzyme, not it's, or quantity of the enzyme. It's not a quantity associated with the. Ooh, but this is the reaction X. I was reading it as a substrate X. Okay, so enzyme E catalyzes the reaction X. So if E isn't working too well, what's going to be changed? KEQ isn't going to change. Boltzmann constant, I can't totally remember what that is. Heat of the reaction, not going to change. I think it's rate constant. I really hope it's rate constant. Yes, it's rate constant. Okay, let's see, because I wasn't totally sure there. Okay, denaturation of an enzyme will alter the kinetics of a reaction that it catalyzes. Right, not thermodynamics, kinetics. The kinetics of a reaction can be characterized by a rate constant. Okay, so this was way more straightforward than I was thinking. Denaturation of E is most likely to affect the rate constant associated with X. Awesome. Okay, question 6. The induced fit model of enzyme binding states that which of the following molecules alters the enzyme active site to more closely match the shape of the substrate? Okay, induced fit model. Which of the following molecules alters enzyme active site to more closely match the shape of the substrate? Do we have a cofactor, a coenzyme, an allosteric effector, or the substrate? I'm going to go out on a big limb here and say the substrate. And I was right. Okay, so cofactors, coenzymes, allosteric effectors, I think all they're talking about there is just the performance, not really the substrate binding. So let's look at the hints real quick. A substrate for an enzyme is the reactant of the reaction that the enzyme catalyzes. An enzyme and a substrate must come into close physical proximity for binding to occur, and such proximity can introduce physical forces that alter the shape of the enzyme. The induced fit model ends. Okay, so yeah, it would have been just trickery for anyone to have picked anything but the substrate. Okay, question number 7. The active site model, also called the lock and key model, of enzyme substrate binding differs from the induced fit model in which of the following ways? Okay, so lock and key is different from induced fit. How? Is it the induced fit model holds that the shape of the substrate is irrelevant to enzyme substrate binding? The shape of substrate irrelevant. I don't think it's irrelevant, and that's a strong word, so I typically steer away from that. The induced fit model holds that the shape of the active site is permanently altered. No. The induced fit model holds that the shape of the active site are altered during this course of substrate binding. Yes, absolutely. The induced fit model holds that enzyme substrate binding does not take place at the enzyme. Okay, so it's definitely the induced fit model holds that the shape of the active site is altered during the course of substrate binding, and we got it right. All right, strong work, boys and girls. Um, which of the following enzyme types catalyzes the formation of a single bond between two substrates through the elimination of H2O? Okay, so there's your big hint. So okay, formation of a single bond between two substrates. Okay, so hydrolase, I'm pretty sure, is the addition of H2O to break a single bond. I think ligase is that condensation reaction to form a single bond by getting rid of water. Isomerase, definitely not. Oxidoreductase, I don't think so. It is ligase. Nice. Awesome. Yeah, people. So don't get fooled by hydrolase. That is breaking something with water. Okay, question number 9. Enzymes undergo a decrease in catalytic efficiency in the presence of excess temperature. Okay, they decrease in catalytic efficiency with excess temperature, okay, but can regain this efficiency once temperature returns to normal. This suggests that increased temperature does not disrupt which of the following aspects of enzyme structure? Okay, hydrogen bonds, peptide bonds, van der Waals forces, hydrophobic interactions. Okay, this seems like it's too obvious with peptide bonds. Yeah, so good rule of thumb, everybody, if you see primary structure, just choose it. Primary structure probably is not going to get altered unless you have another enzyme acting on a protein. Okay, local conditions can affect the specificity of an enzyme for its substrate, and thus the enzyme's catalytic ability. Which of the following alterations would most likely not affect an enzyme in this manner? So we're talking about local conditions affecting specificity. Thus, catalytic ability will be affected. What would not affect an enzyme in this manner? Okay, increased concentration of hydrogen, increased concentration of hydroxide. Those can probably both get ruled out for one reason, because they're opposites. Well, hold on a second. Maybe not. Okay. Increased temperature, increased substrate concentration. Okay. So local conditions can affect the specificity of an enzyme for its substrate. One of those local conditions is not going to be the actual substrate just being there. So I'm going to go ahead and say it's that. Okay, it's true. So let's look at the hints real quick, because this was a little bit of a weird question. Okay, so the specificity of an enzyme for its substrate is partially governed by the shape of the enzyme active site. Right, that's the induced fit model. An enzyme active site is stabilized by non-covalent intramolecular interactions. Non-covalent intramolecular, yeah, that's like the, what was it, a serine, threonine, kinase, histidine, whatever that thing is. It's, yeah, non-covalent intramolecular interactions. Okay, non-covalent intramolecular interactions are affected by heat and pH, amongst other things. Alteration in substrate concentration, yeah, wouldn't affect it. All right, I got 9 out of 10, but to be fair, like 1 or 2 were kind of educated guesses, so I'm not quite there yet on content review, but regardless, just strong work, gang.